Right, question 6 is the electrostatics question. We've got two small charged spheres, X and Y, on insulated stands, 10 centimeters apart. Notice the units there, centimeters. We're going to need to change those into meters for equations. The charge on sphere X is minus 7.5 nanocoulomb. So notice it's a negative charge. The nano means 10 to the minus 9. Charge on sphere Y is known to be positive. It's important to notice, but the magnitude's unknown. So X is negative and Y is positive, so we've got opposite charges, and so we know that there's going to be a force of attraction between X and Y, and one of the later questions asks us to calculate that force. Alright, 6.1 asks you to draw the electric field pattern around two charged spheres. You really just need to learn these field patterns off by heart, but let's just have a look at them. We've got two charges, negative and positive, so opposite charges. The field between them looks like that. Remember, the direction of the electric field is a direction in which a small positive test charge would move, so towards negative and away from positive. And then on either side, around a charged sphere, the lines are drawn as shown on either side, making sure that the direction is indicated correctly. Alright, 6.2, how many electrons were added to sphere X to create the charge of minus 7.5 nanocoulombs? The formula is charge is equal to number of electrons times by the charge of one electron. Q subscript E is the charge of one electron, and that you get from your data book. So we know that the charge is minus 7.5 times 10 to the minus 9. The question's asking to calculate n, the number of electrons, and the charge of one electron is minus 1.6 times 10 to the minus 19 coulombs. And if we solve for n, we get 4.69 times 10 to the 10 electrons. Alright, 6.3, why the charge is placed on insulated stands. Just to remind you that, remember, X is negatively charged, and what that means is that there's a build-up of electrons on sphere X. Y is positively charged, which means there's a deficiency of electrons. Okay, we don't build up the positives, those are the protons in the nucleus, but there's a deficiency of electrons. Now, there's a drive in nature to equalize charge, and so in terms of sphere X, the drive would be for those electrons to be transferred down the stand into the Earth, and on Y, the drive would be for the electrons from the Earth to be drawn up to equalize the positive charge. So that's the drive in nature, and to prevent that from happening, we need to put them on insulated stands. And insulated simply means that it doesn't allow a transfer of electrons. So the answer is that the insulated stands prevent the leakage of charge to or from the Earth. So electrons can't either go down into the Earth from X or out of the Earth up onto Y. Alright, 6.4, name and state in words the law which can be used to calculate the force between two charged objects. The name of the law is Coulomb's law, and the statement is the magnitude of the electrostatic force between 2-point charges is proportional to the product of their charges and inversely proportional to the square of the distance between them. Okay, 6.5. If the force between the charged spheres is 4.05 times 10 to the minus 5 newtons, calculate the magnitude of the charge on sphere Y. Alright, so let's start with the statement of Coulomb's law. F equals K Q1 Q2 over R squared. That's from your data book. Make sure you put it down correctly. F is given as 4.05 times 10 to the minus 5. K is a constant, 9 times 10 to the 9. Q1 is 7.5 times 10 to the minus 9. Now remember, we're not interested here whether it's positive or negative charge. We're simply interested in magnitude. Q2 is what we're looking for. Now the distance between the charges, remember in the question it was given as 10 centimeters, and you need to change that into meters, the SI unit for this equation. And so 10 centimeters is 0.1 meters, and then you need to square that. And if you solve for Q2, you get an answer of 6 times 10 to the minus 9 coulombs, or 6 nanocoulombs. The The question just asks for the magnitude of the charge. We know it's positive because that was given in the question. All right, 6.6. Two spheres are brought into contact with each other and then separate. Calculate the new charge on each sphere. The key principle here is when you bring two charged objects into contact with one another, then the charge equalizes over the two objects. And so the new charge Q is simply the sum of the original two charges, and then you divide that by 2 because it separates into half on each object. So Q1 is minus 7.5 times 10 to the minus 9. Now we really do need to keep track of the positive and negative signs to indicate positive and negative charge. Q1 was a negative charge, and we need to add that to Q2, which is plus 6 times 10 to the minus 9. We've just calculated that, and then divide that by 2. And that gives us an answer of minus 7.5 times 10 to the minus 10 coulombs on each sphere.